Boger, and I will be the moderator. We are very honored to have 4 distinguished panelists talk about their research and their connections to Globe citizen science. Their bios are up on the website, and I encourage you to look at them. They will be talking about a variety of different types of applications in their research, from forests to mosquitoes, snow, and icebergs. We will start with Duan Biggs and Jenna Keany for engaging citizen scientists for inclusive Earth systems monitoring. They're from the Northern Arizona University. This will be followed by Yi Young at the University of Florida, then Marco Tedesco, and finally by Maria Burnett. So without saying more, let's move on to learn from them as to how they are integrating Globe citizen science in their research. Thank you so much.
Thank you. My name is Duan Biggs. I'm presenting today with the postdoc leading this project, Jenna Keany, and also in our room is Mariah Williams, an intern working on our project in the forests around Flagstaff. So a key challenge, next slide, please. A key challenge that we have is that NASA's estimates for above ground carbon from the GEDI instrument needs additional ground truthing. At the same time, especially in the global tropics, where I've spent a lot of my career working, there's lots of rural communities, local people that are living in and around those forests, and many of them are unemployed without, necessarily all that much to keep them busy with, and potential for them to be involved in helping us collect data. There's a real opportunity to involve these people in ground truthing what NASA satellites are observing. Next slide, please. So our project aims to address these multiple challenges and will engage citizen scientists to collect data on tree height, diameter, and species that provide on-ground validation to improve NASA's Earth systems monitoring GEDI L4A biomass product. We will also assess the motivations and preferences of local communities and rural people to participate in collecting citizen science data using Globe. And then we will also expand the use of Globe by engaging with Globe Citizen Science Network across 4 countries: Kenya, here in the US, Ecuador, and Malaysia, or a neighboring country in Southeast Asia. And here in the US, we'll also be working with tribal nations. Over to you, Jenna.
Next slide, please. Perfect. So the main goal here, of course, is to validate those GEDI above ground biomass estimates using the Globe Observer mobile app, which I know everyone here is familiar with. So what we're doing is training citizen scientists on how to use the tree protocol and specifically upload the tree height data, the DBH or the diameter, breast height, and the tree species within GEDI footprints. So we want to make sure that we are validating actual GEDI data by getting citizen scientists to these GEDI footprints and then taking pictures of trees and measuring trees within those so that we can really know how accurate is GEDI at estimating our above ground biomass there. And this will help us validate and improve. So we will be working with NASA's GEDI science team to improve their algorithms using the citizen science data. So it's really, really exciting. We're kind of working across the board with different NASA groups. And yeah, we're really excited. So we just got funded. We're just getting started on the project, but we'll have more updates as we continue. And then, of course, the second main project goal is to develop this Globe framework for development. And we're going to be using focus groups in Kenya and the US tribal nations. And so we're developing a framework where we will engage with rural and low income regions to really understand how can we best incorporate them into NASA citizen science programs. And so we'll be starting that very exciting in Amboseli, Kenya in January 2026. And that's all we have for today. I know it's a little bit short, but I know there's going to be a Q&A, so please post your questions if you have any, and we'll get back to you. So thank you so much, and please contact us if you have any additional questions with our email there.
Hi everyone. My name is Lee, and so today I'm gonna talk about some AI machine learning and observer about citizen science globe observer program in lung cover and mosquito habitat mapping. So I think this is a very important time as we stand at the intersection of the 3 decades of the global program, and also we are at the cutting edge of AI innovation. So we are seeing a lot of great opportunities for enhance those global environmental monitoring capacities. So my research team at the University of Florida is collaborating with NASA, has developed a lot of frameworks that amplifying the citizen science value for data and through different machine learning algorithms. So next slide, please. So let's start with the global observer lung cover. So the global observer lung cover protocol, we start with the protocol, really has a fundamental advancement in citizen science methodology. So through its very innovative, that multi-directional sampling protocol approach by 6 different directional view. So the citizen science collect the standard photograph from all different 6 directional view with a 100-meter radius. And this is a very unique protocol creating very comprehensive visual data sets that with a lot of information. So the systematic approach ensures the volunteer observation maintain really scientific rigor where we are trying to get the accessible data. And we are in the scientific side, we are really trying to provide a methodology to approve that, this lung cover methodology and the protocol really can make a difference in the lung cover and lung cover mapping accuracy. Next slide, please. So we develop AI machine learning algorithms for the classification framework by fusing all those different views together. And those classification, so we have early fusion, late fusion, and score fusion. And this end-to-end system analyze single view, double view, triple view, and quadruple view in different combination. And we are demonstrating a really progressive improvement in the lung cover classification accuracies. And then we are trying to use different machine learning and AI algorithm, for example, like the VGG, ResNet, MobileNet, and EfficientNet to consistently show how are they differentiate. So those all 6 different directional view got up to a 15% over the single view approaches. So this is showing how powerful citizen science and how powerful the protocol are. Next slide, please. And here we are going to, so here is my project about the global mosquito habitat observer. So the global observer mosquito habitat mapper. So this protocol really enable the citizen scientists to document and classify different diverse breeding sites of the mosquito habitats are. So this is a very important linkage between the ground truth data into the remote sensing Earth observation data by NASA by the microclimate. So this is the distribution of how actually the climate are, and those are the pictures that in the global observer mosquito habitat that really showing the linkage. So those data are very difficult for scientists to collect in a very short period of times. So and this protocol really strengthens the ability to capture the fine scale spatial and temporal variations. Next slide, please. And so here is our new project funded by NASA, so called the eMERGE. So the eMERGE initiative represents a transform like a really innovative approach to the mosquito-borne disease forecasting that integrate the globe citizen science data with the Earth system models and the NASA Earth observation data. So our framework got around over 80,000 globe participants um, across 100 countries, creating the near real-time monitoring capacities to really help making the public health decisions. So this is a system AI powered integration combine the global data set with the NASA Earth observation satellite, and then we will do incorporate the climate modeling to predict the disease risk patterns under different scenarios. And so here we are also really helping the open source data science participants. We provide decision making with the accessible tools and the scientific applications. Next slide, please. And so we have a lot of previous success in the state of called Wyoming. It's a very rural state and the population density is the lowest. So we want to really fight against the spatial bias of the citizen science by hosting data campaigns. And so here I'm really like calling for action. For the mosquito habitat, the eMERGE program really invite the global community to participate in the next generation for environmental monitoring through the collaborative and machine learning workshops. So we are going to host a series of workshops, and we are also like trying to develop a lot of tutorials how to use remote sensing data and in combination with the citizen science data from the Globe Observer. So yeah, I think I'm happy to answer questions, and please join our email list. Yeah, thank you.
Thank you so much. I'm Marco Tedesco. I'm from Lamont, Doherty Earth Observatory, and we have this project called X-Snow, which focuses on snow. And we started very recently, about 6 months ago. Next slide, please. I wanted to acknowledge the co-PIs. Actually, Margie Turin, she's the educational and outreach coordinator, and I call her the health PI because her effort was instrumental. There's no such a thing as a co. Lamont Doherty Earth Observatory is basically the core science center of Columbia University, and it's located in Nyack on the Hudson River in a beautiful place. So if you happen to be in New York City, just come visiting us. We're about 20 minutes, 30 minutes outside. So Margie is our coordinator outreach. Marisa Annunziato, she is sorry, I'm starting my timer. She is education outreach. And also we now have Still Abdul, who is gonna help with the social media manager. You can see the logo and of course the website. Our goal is really to understand the snow properties and improve our tools to validate remote sensing estimates and models. And the East Coast, we're focusing mostly on the East Coast. And the reason is because the East Coast has been historically underrepresented in terms of data sampling and the snow that is on the East Coast is very different from the snow on the West Coast in terms of when it forms, when it melts, how quickly it goes away. So we have really little data there. We have created some partnerships with the Catskill Center, Adirondack Wild Center, and other schools. Next slide, please. And again, we started about 6 months ago. Next slide, please. I just wanted to highlight with this slide that, again, there is so much investment on the understanding the snow on the West Coast. And I've been studying snow for the past 25 years from space and ground. And it's astonishing that because of cultural, financial, and historical reasons, there's very little understanding and mapping of the snow properties on the East Coast. And this is exactly why we started XSnow several years ago. Then the pandemic happened, so we were on a dormant phase. But then with a new call, we were able to get funded, and we again are looking forward to continue and grow the community that we're building. Next slide, please. I just wanted to highlight very briefly that we have different protocols. We are asking people to collect mostly for the early adopters, snow depth and some meteorological data, and we have different tiers. The tier 1 is the very simple one, in which we ask people to collect snow and pictures of snow. We have the tier 2, in which it's a little bit more sophisticated, and you will find everything on our website, in which you have snow depth, albedo, so how much light is reflected by the snowpack, and then other properties like snow grains and so on. The third tier instead, it involves the digging of a snow pit. So basically, it's a snow. You dig a snow pit. You start looking at the different properties that we usually look on the surface throughout the vertical length of the snowpack. And this is really for what we call the snow ambassadors, those ones who are really hardcore snow lovers and can train also other people. One thing that I wanted to point out, there are two things. First, we're also flying a lot of drones because, drone flights, because we are building snow depth changes from the photogrammetry that the drone is giving us. And so we can assess the measurements on the ground. We can also validate the drone data, but at the same time, we can also have large areas covered in terms of understanding the thickness of the snowpack. We're also asking people to collect snow as it falls or right after it falls, so that we can characterize the microplastics content in the snowpack, because to our knowledge, there is really no knowledge of the processes, the temporal distribution of microplastics within snow. And we think this is extremely important for several reasons. Next. Yes, thank you. We wanted to thank, of course, the funding and program managers, Sarah Kern and Mark Kushner, but also I think what I saw so far, we also are implementing the GLOBE protocols when people take pictures. So we ask them to take the pictures looking in different directions, up and down. And the area where we are at, there is a lot of trees. And I've been looking now at the presentations that our colleagues have been giving. They have been amazing. And I was wondering if, also there is any interest in getting the data or pictures from the trees that people are already collecting. I'm pretty sure there'll be more conversations about this. And we're looking and we're considering now organizing a snow school that is going to be held on the East Coast, likely in 2026 in the winter, and where we're going to try also to better understand the protocols and how we are going to integrate the work from the students, from our colleagues at NASA, and how and the community they were working together with. This is my last slide, so thank you so much for having me and for inviting me.
Hello, everyone. My name is Maria Vernet, and I'm an oceanographer. We are doing something that is a little bit different than I think everyone else, in which we do not have the perfect app to do our work. So talking with the wonderful people in the Globe Observer and Amy and Holly, they suggested that I use the app tree that you are familiar with to try to see if we could then measure icebergs. So this is what I would like to present today. We just started the project last month, so I don't have a lot of data to present, but I just want to present the idea, and hopefully in 2 years for the next Globe meeting, I will have some interesting data. Why do we want to measure icebergs? Icebergs is one of the ways in which the ice sheet, which is a big ice mass on top of continents like Greenland or Antarctica, deliver ice or meltwater into the ocean. So this is like rivers of ice, which we call glaciers, that they deliver this ice and this meltwater, both things, into the ocean. But the icebergs or the ice comes in huge variety of sizes, and we call them different things. We call them growlers and bergy bits, and they are small, less than a meter. We call it small, medium, and large icebergs. If now they look more like a truck, that's what I would call them. And then very large icebergs, which are the biggest that I worked in Antarctica. It took the ship 8 hours to steam around the iceberg. This is an equivalent of 80 kilometers or 50 miles. So how do then we measure icebergs? We measure them from remote sensing, but we also need to ground truth that data. So the idea is to use citizen scientists to obtain data from icebergs around Greenland coastal waters to try to characterize and ground truth remote sensing data. So what have we done? We train the tourist industry in polar regions have become more sophisticated, and they attract their guests by also providing access to citizen science projects. One of them is like ours, in which the guests get on from the ship into small boats and collect samples for us. They take CTD data, which gives salinity and temperature, collects water for phytoplankton, for meltwater measurements. And now we have added, please go around and measure the icebergs that you see. They can also do it from the ship. It doesn't have to be in a small boat, like for collecting water from the surface waters. But I think the small boat gives them, is a small group, it's only 8 citizen scientists, and they then can be trained by the guide on how to do the science. If we look at the next slide, I wanted to say, why are icebergs important? So in 20 to 15 years ago, I was involved in a large iceberg project in Antarctica. And after, with several other co-principal investigators, and basically what we found is that the iceberg is its own ecosystem. What we see is only the top part, is a little piece of ice or a big piece of ice that is usually between 5 and up to 30 meters high. But the big mass of ice, as we all know, is underneath the water. So what is it that the iceberg does underneath the water? What the iceberg does is attract a lot of organisms. And then these organisms interact with each other and they create their own system, their own food web. And there are processes here that I don't want to go into detail because it's too much, but I just want to give you the idea that underneath the surface of the ocean, the iceberg is what we call a hotspot of productivity. And it has processes like melting, which is physical. With the melting of the ice comes nutrients or fertilizers that supports growth of phytoplankton, and it attracts and maintains zooplankton like krill or copepods. So this is a very dynamic system because the iceberg is not stable. It translates with the currents. It bobs up and down with the waves, and it also rotates. So it is a challenging, interesting system to look at in the ocean, and that's why we think that constant observations through all the summer season by the citizen science is a way of really catching all their evolution through the summer. So if we go to the next slide, I will explain a little bit how we have adapted the tree app to use for icebergs. What the app provides is a consistency in taking information of icebergs, the geographical location, and also a possibility to store the data that is findable. We have added to the app a rangefinder. A rangefinder is a piece of technology usually used more by hunters, for example, in which you can, with a laser, find how far away you are from an object. In this case, how far away you are from the iceberg. And we also take additional photos about the height and the width, the distance, and everything else we can think of. All that information now, because it's not taken directly into the app, goes into the notes. So we are now working on how best to use this metadata to combine with tree app information. And the sophisticated rangefinders, the more expensive ones, also give you additional information like wind speed and direction, air temperature, humidity. So it becomes a way of obtaining all the information that we want to model, because that is already available, to model the size of the iceberg, the location of the iceberg, the air temperature, the ocean temperature as the iceberg melts and introduces new meltwater into the coastal waters. So I just want to thank everyone for being, so welcoming to the GLOBE community. And these 2 days have been my introduction to the GLOBE program, and I have been very impressed. I definitely can see how we can contribute new data into the GLOBE program, and hopefully have more access to polar data. Thank you. And I'd be more than happy to answer any questions you may have.
Well, thank you all for your excellent presentations and very exciting applications of citizen science for your research. So I'd like to ask 1 or 2 questions, and then we'll move on to a question from the audience. But in looking at this and very wide applications and different applications of citizen science in their involvement and how they involve. So what can the GLOBE community do to support your work?
Yeah, I would say that definitely we are going to expand the project to provide this type of access to GLOBE and technology to the villages in Greenland, working with the teachers in the different villages, because they live there, they know the environment, and they see all these icebergs coming from the glacier all the way in their way to the ocean. So, for example, I am interested in helping everyone or training everyone that might be interested. If any of you will go on a cruise to Antarctica or the Arctic, then let me know, and we can also work on it. So basically, polar regions are always undersampled so we use anyone going into these polar regions or living in the polar regions as a way to get excited about the science going on and for us to get help on collecting data.
Thank you. Marco.
Okay. Yeah, Maria, hi. I think we spoke a while ago, and besides, it's great to see you again. Besides snow, I also work in Greenland a lot. So I think what you're mentioning is resonating very strongly. I'm thinking also about, unfortunately, the boom of tourists in Greenland, Ilulissat especially, and the construction of new infrastructure like Southwestern. Maybe we can benefit from pointing a camera and using cameras that can start collecting some data as the icebergs pass by, and we can make the best out of the worst. But also I was thinking I saw the presentation about mosquito. I was like, oh man, this is so great. And also, I don't know if people are aware, but Greenland during the summertime, if you camp in the tundra, there are mosquitoes that are as big as, I don't know, if a dollar coin. I was wondering at some point if Dee might be interested, or the other person, I don't remember if it was Dee, was interested in maybe talking more about what are the data that can be collected there in some areas, so that they can probably add another geographic and ecosystem region to what they are projecting, because Greenland future, warming will be also interesting to see how the ecosystems are going to fight to protect their real. So overall, just synthesizing, I think in our case, when we take pictures, I would love to have people for me to to have access to what is being metadata collected, how do we organize it, maybe having a search engine that will allow us, for those of us who are collecting data, to reach out to people. Like we have a lot of data on trees, and I understand, people are doing their own job. And also we have people, volunteers, who are doing the spring and summer. They have nothing to do really because there's no snow on the ground. So maybe, I don't know if it already exists, but try to connect more the dots and try to make ourselves more in the position to metadata and dry a joint globe training would be fantastic. Yes, Jen. So anyway, this is what I was going to go. I don't want to take more. I know there are other questions, but I'm extremely excited to be here, and thank you so much anyway as well.
And thank you. I mean, we're all excited with you, all of you, and your work. But moving maybe from more of the polar regions or colder regions to more temperate and tropical regions, with either Dee or Duan share ways in which Duan, I see your hand go up, so I will ask you to speak.
And the question was again how the Globe community could help us advance what we're doing, right?
Yes. Yes,
and
correct.
I think these sorts of interactions are fantastic. And so we'll be reaching out to you, Marco, and probably Maria to understand what you're doing, because we're also trying to use the Globe Tree app. One of the issues is, and perhaps through these discussions we can get there, and I do hope that soon we can have a Globe meeting in person again, because it'll just be fantastic for us to be able to, have a coffee or a beer and share these ideas. But one of our challenges is with our work thus far in Kenya is that the technology people have on the phones they have, the Globe app, is very clunky and really doesn't work very well. And that's something, and then in addition to that, the additional information we'd like to collect, how to most effectively do that. And speaking to partners and collaborators with Globe, that would be useful to understand how they navigated that. But also as we move forward with the team within Globe working on the app, would be helpful to be in touch with them and understand, what the possibilities are there.
Excellent. As it improve the capability of citizens to participate easily. Yeah.
Absolutely.
Awesome.
Yes.
Okay. Yeah. Dee.
So from the research perspective, for scientists who want to reuse how the Globe community can support. So for the citizens, for the researchers who are reusing those data, that would be great that we can create some dedicated research-oriented data portal with the API access that will streamline a lot of the integration for the data visualization and all those data access.
Thank you so much. Jackie, are there questions in the Q&A that you would like to have ask the presenters?
Yeah, one of the questions was about, I think this might be for Duan. Will the rural low-income people contributing ground observations be compensated? That might be for, I don't know if that question is for all of you or just one of you.
I mean, that's the longer term vision, obviously, in terms of the current project we have. They'll be, we're not going to pay them from the grant we have, but our vision is that through verifying how much carbon there is in the system, that we will explore the linkages to payment systems, carbon markets, biodiversity credit markets. So that's very much the longer term vision that we are working towards and exploring.
So I just wanted to follow up what Dee said, and Duan, this is very important what you said. I just wanted to go back 1 second, but I think one thing I learned from my experience as a rotator at the National Science Foundation Polar Cyber Infrastructure Program, very long way, but just basically that metadata reuse and discovery is even more important than the data itself. I don't think we have to really overload our system to share the data, because then you have dynamic tools and it gets bigger. But I think coordinating on metadata discovery and standardization, this was something that really came up from the community feedback when I was there. and it could make a big difference, and it should not take too long in terms of resources, as long as we create good standards and we coordinate, because after all, it's just a bunch of text files, which have the power to unlock a lot of resources. I just wanted to mention this. But
Yeah.
that's a great idea.
Thank you, Marco. Thank you for that. Another question from a Globe educator. Very interesting presentation on GEDI program. Which indigenous tribes are you working with in the United States?
For that one, as Jenna mentioned, we're just getting started. So Mariah sitting here is from the Navajo tribe. We have a Northern Arizona University situated in Flagstaff, is surrounded by tribal nations, and we're working with the indigenous tribal environmental professionals at the university to reach out to various schools and groups to make appropriate connections to the tribal groups. Having said that, we are not restricted to tribal nations. We also engaging other rural communities, including ranches that may want to take part. So it's rural communities, and for our location, tribal communities are an important part of that. Mariah, I don't know if you have anything to add. You've been going out into the field collecting data?
Yeah, I have been.
Or Jenna?
Yeah, no, I think that's a good start for sure for us, and we're looking forward to making additional connections.
Great, thank you. There's a question in the chat from Angie Rizzi. I am in an area where we often lose trees during snow ice storms. Would there be any interest in trying to determine the loss of trees in these types of events?
Absolutely, yes. I think, especially nowadays where you have all this increased concentration of extreme events, both in terms of snowfall and storms, I think for the snowpack, it's crucial because the trees, they are protected by the snowpack, but also they control the redistribution of snow on the ground. And I assume for Duane and others, this might be also important because it can help understanding, but besides validating the remote sensing data, but it can help understanding also what is the impact on the carbon and on the ecosystems. And once you start, to me, the beauty of this is that in a few years, we will have all this data collected somewhere, and somebody young, smart, and very driven will come out with some great ideas. And all we have to do now is just to keep building blocks that interact with each other. So definitely it's something that would be very interested for the local ecosystem. And I'm pretty sure also the locals, the people who live on the mountains, they know a lot about what's happening, and they could also contextualize the pictures, which will be another aspect that we as citizen science working with people can benefit from. A satellite is never going to tell us what happened, and ChatGPT is only as good as we train it. So the memory of these people is very important to be ingested into the quantitative data.
Great, thank you. Another question from Dr. Evangeline Harris. How can all of you consider ways to engage students in high school to motivate them to become scientists, perhaps from grade 9?
Well, we visited in southern Kenya earlier this year to scope out our project. We met with some of the local schools around Amboseli National Park, and the teachers were incredibly enthused, and that's a very low-income part of the world. And any opportunity to collect data associated with particularly a powerful global brand like NASA, there was a lot of excitement for that. And I think that opens up opportunities and exposure to those students to then potentially see that they also can become scientists.
So another one about GEDI, as with several NASA satellites and instruments like ISAT-2 and GEDI that observe tree height from space, there's a data latency or time delay between data acquisition and availability that's involved with the data. So how do you plan to address this issue when asking for specific Globe Observer citizen science tree heights in specific locations or during specific times?
Yeah, I can answer that. So essentially what we're doing is really just taking any available GEDI data, and that is because with GEDI's orbit on the International Space Station, we can't particularly, fill in the gaps. If you're not familiar with the data set, It kind of shoots a laser down at the Earth, and you get kind of GEDI shots, or like kind of circles, where we have estimates of above ground biomass and tree height. So what we're really hoping for is that there isn't going to be too much of a change from when we're asking citizen scientists to collect the data and from when it was collected. And we are lucky enough that GEDI really did just start collecting data in 2019, so there isn't too much of a time lag there. But with our connections at the GEDI science team here at Northern Arizona University and then at the University of Maryland, we're working kind of directly with the scientists who are grabbing those data sets from the portals as soon as they're available. So those are kind of our methods there. But yeah, of course, we would love it if they would line up within 6 months or a year. That would be fantastic. And we can probably maybe even try to prioritize, like, hey, go to this GEDI shot if it was just collected in 2024 versus 2019. Yeah.
Thank you. There's a theme in the chat about the importance of connecting with tourism as an opportunity. So that's interesting, where it might be applicable to each of your projects. Any other questions, Jackie, in the Q&A?
Yeah, just one more, in addition to some questions that are in the chat as well, but a question for Marco. If we want GLOBE participants to collaborate with you, can we use the GLOBE snow-related protocols as is, or do they need to use your protocols? And how feasible would it be to come up with a common protocol similar to your Tier 2 protocol?
Good point. We are really pushing the GLOBE protocols on our side, and we want to merge the feedback of the people in terms of, and what we learn from them to with the GLOBE protocols. I don't think it makes any sense if we go in different directions. And especially because you find different levels of friction or fluidity in terms of how people react to the protocols when they're explained. And having these good, clear directions of protocols that can go from students to elderly to retired people to active people, and they can interact on a common base that's been tested, I think this creates community, not only in terms of how the people learn, but also how they interact, because at some point everyone can share with everybody else in these level things, which is extremely important for the citizen science. So I have no problem in bending or breaking any rule we've fixed so far if we have to merge with GLOBE, because I think we also have to be practical and try, as we discussed, try to move towards more a coherent metadata section, and this starts from the standardization of the protocols, of course. So thank you so much.
Metadata is very important, for sure. Another question for you, Marco. GLOBE Italy and Deakin University in Australia are interested in microplastics and snow monitoring system from space. Are schools collaborating with you for the ground truth?
No, but I would love to. I'm in Italy actually right now, so I have to apologize. I will have to leave soon, but this is exactly the kind of opportunity that GLOBE and this kind of meeting can promote. We also had somebody who just traversed Antarctica from the coast to the South Pole, who collected, snow samples for us, and we are analyzing that. So I'm very interested in this, and of course, beside the hype and the current cultural thing, we really need to start understanding the positional and evolution on the ground of properties of the microplastic if we want to start understanding how to plan things. Otherwise, now we just know that it's bad and we have no clue. It is impossible to start showing quantitative data, and we need that. So I'm very happy to expand and reach out. I think Sandro, nice to meet you.
Yes, and in the chat I'm reading, all of you have generated a lot of enthusiasm and discussion and are asking about ways to participate, be it a network of different universities that a person is a part of. So I'm sure that there's going to be a lot of continued discussion and involvement through GLOBE in your respective projects. Any more questions there that we need to address, Jackie, from the Q&A?
No, I believe all of the questions are in the chat, and
I think we're running out of time.
yeah,
Are we?
I think we are.
Maria.
Could I just say one thing?
Yes.
I just
Yeah.
want to, I mean, the citizen science community or participatory science community is as big as globe, and I can see a great collaboration between those two huge international things. So it's something to really think about. And
Mhm.
for anyone wanting to take action in climate or sustainability of everything, both communities are super. So I think there is a lot of possible collaboration in the future.
Great, thank you so much. For all of the work that you're doing and your commitment to advancing earth science and involving the communities and citizen science in the work that you do. Very inspiring. Anything else, Jackie, before we move on to the next session?
Yeah, I just want to say thank you to all four of you, actually to all of you that are in the room with Duan as well. Thank you all for your work. I'm super excited to hear about these connections and to hear what this enables moving forward.